In this video, we're going to talk about the greatest common factor and the least common multiple and the ways that we can find it. So just a reminder, GCF stands for greatest common factor. And what that means, a factor is something that divides into a bigger number. So it's usually smaller than your number you're starting off with. The greatest common factor is going to be the biggest number that divides into both numbers or all three numbers or whatever. So this is the biggest factor that divides into your numbers. Okay, so we actually have two different ways we could find the greatest common factor. The two different ways to find, the first way we can do it by listing all the factors. And then the other way is by using prime factorization. Okay, so let's start off with listing out all the factors. So the way that we list out all factors and find the greatest common factor is you list out all the factors and choose the biggest one they have in common. So choose the biggest they have in common. Okay, so for example, if I wanted to find the greatest common factor of 12 and 16, the first thing I would do is list the factors of 12. So I think through, what things multiply to give me 12? Well, 1 times 12. What else? 2 times 6. And then what else? 3 times 4. So this is all the factors of 12. 1, 2, 3, 4, 6, and 12. Okay, those are all the numbers that divide into 12. So notice that all those numbers are actually smaller than 12, except for 12 is the same size. So your factors are numbers smaller than or equal to your original number. Factors of 16, numbers that divide into 16, well, 1 and 16. We also have 2 and 8. And then 4 times 4, I only need to write 4 twice, or 4 one time. So now that I have all my factors listed out, the greatest common factor of 12 and 16 is the biggest number they both have in common, which is 4. So you would write your answer, greatest common factor of 12 and 16 equals 4. Okay, so this is one way to do greatest common factor. It's not a bad way. It definitely works. It just gets to be not quite as much fun when your numbers get big. Like in this case, we did 12 and 16. What about if we were doing 12,000 and 16,000? Like I don't really want to list all the things that multiply to give me 12,000 and all the things that multiply to give me 16,000. So there are other methods, and one other method is the prime factorization. Okay, so for the prime factorization method, we are listing all the prime factors. So before we just listed factors. Here we're listing prime factors. So I don't know if you remember what a prime factors is, but the prime factor is like when you break a number down to the smallest prime numbers, like all the small numbers that multiply to get it. So for example, for 12, if I broke it down, it would break down into, I could start off with 6 times 2, or I can start with 4 times 3, doesn't matter. 2 is a prime number, 6 is not a prime number. It can break down into 3 times 2. So the prime factorization of 12 is 2 times 2 times 3. It's the prime factors that multiply to give you that. Okay, so that's called a factor tree. So we list the prime factors, which is the factor tree. And then once you have the prime factors of your two numbers, you choose all they have in common. all they have in common and multiply them. Okay, so let's do an example like that. Let's do the same problem for 12 and 16. So if I wanted to find the greatest common factor of 12 and 16 using the prime factorization, the first thing I do is break down 12 and 16 to my factor trees, or using my factor trees. I already did 12. Let me do it again, but this time let me start with 4 and 3 and show you get the same numbers no matter what you start with. 4 breaks down into 2 times 2. 3 is a prime number already. So the factors of 12, the prime factorization of 12 is 2 times 2 times 3. 16 breaks down into, you could start off however you want. I'm going to start off with 4 times 4. 4 is not prime. It breaks down into 2 times 2. Same thing over here for this form. 4. So 16 is 2 times 2 times 2 times 2. So then my answer is circle all the factors they have in common and then multiply them together. So they have a 2 in common. They have another 2 in common. So the greatest common factor is 2 times 2, which is 4. And technically you should write your number in front. The greatest common factor of 12 and 16 is 2 times 2, which is 4. Okay. I can also, for prime factorization, I can put this in a Venn diagram. Okay, so my factors of 12 and my factors of 16. So this is the prime factors of 12. You can't do it with the regular factors, just the prime factors. And this is prime factors of 16. So what numbers multiply to give me 12? 2, 2, and 3. Okay, so when I go to put this over here, to get me 16 is 2, 2, 2, and 2. They both have a 2 in common. Actually have 2 2's in common. So 12 is 2 times 2 times 3. 16 is 2 times 2 times 2 times 2. So I hope that makes sense from our Venn diagrams, our sets that we were doing before. Prime factors of 12, 2 times 2 times 3, which is 12. Prime factors of 16 is 2 times 2 times 2 times 2, which is 16. They have the 2's in common. So the greatest common factor is actually the intersection of your two numbers. Here's where your GCF is. Okay, so kind of relating that back to something we already knew. Okay, so this is a little bit more, it's a little bit quicker whenever you're doing bigger numbers. If I was doing 12,000 times 16,000, there's not as many combinations for regular factors. There's less prime factors, so it's less work to get your prime factorization of two large numbers and then figure out what they have in common like that. Okay, so let's talk about the least common multiple, LCM. LCM stands for least common multiple. And just a reminder, a multiple is your number times another number. So like the multiples of 12 would be 12, 24, 36, 48. So 12 times a number. Okay, so multiples are numbers that are bigger than your original number. Factors are numbers that are usually smaller or equal to your original number. Okay, so the least common multiple would be the smallest multiple your numbers have in common. Or the smallest number they can both multiply to get. Okay, so we actually have three ways to find this. The three different ways to find this, we actually have 4 ways. Okay, so 4 ways to find it. The first way is I can list my multiples just like I did before with the factors. The second way is I can use prime factorization just like I did with the factors. The other 2 ways I can do for this, I can use a number line to show it, and then I also have a formula for it. Okay, so we're going to do all 4 of those. Okay, so the first way, listing multiples. I do the same way as before. It's just now instead of listing the factors, instead of listing the things that divide into it, I'm listing the numbers that multiply. So if I'm trying to find the least common multiple of 9 and 21. So I'm going to list the multiples of 9, which are 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27, 9 times 4 is 36, 9 times 5 is 45, 9 times 6 is 54, I don't know where I wrote 6, 9 times 7 is 63, 9 times 8 is 72. There's not really a point where you're supposed to stop. It's just, you got to keep on going until you find the one that they have in common. 9 times 3 is 81, and then I'm going to stop there and I'll keep on going if I need to. So now I'm list the multiples of 21. So 21 is not one of my options. 21 times 2 is 42. Is not one of my options. 21 times 3 is 63, which actually is one of my options. So these keep on going, but I don't need to keep on going because I found my answer. So the number that they have in common is 63, so the least common multiple is 63. Okay, again, this is an efficient way, or this is a way to do it. It's not necessarily the most efficient way because if my numbers were bigger or my least common multiple was like a really big number, it would take me a long time to get there, and it's a lot of writing. So we can do the prime factorization. So let's do that. So prime factorization. These papers underneath there. So same thing as before. I find the prime factors. So I find the prime factors. The difference here now is with the greatest common factor, once I find the prime factors, I just multiply what they have in common. Here, the least common multiple is what they have in common. So what they have in common, and what they have in common is the greatest common factor, and then times any factors they don't have in common. Okay, so for this problem, if I was doing the least common multiple of 9 and 21, the first thing I do is find the prime factors of 9, which is just 3 times 3. So prime factors of 9 is 3 times 3. Prime factors of 21 is 3 times 7. So 21 is 3 times 7. So what do they have in common? They have the 3 in common. That's actually the greatest common factor, right? Greatest common factor of 9 and 21 is 3. The least common multiple, the way we figure that out, is we multiply what they have in common, which is the 3. Okay, I got the 3 from here. And then whatever's left over. These two are left over. So I multiply those times 3 times 7. So 3 times 3 is 9, 9 times 7 is 63. Okay, so once again, for prime factorization, get your prime factors, what they have in common, times whatever's left over is your least common multiple. Okay. The third way we talked about was using a number line. This is similar to the first, like doing the multiples. It's just like a picture of it. So using a number line. So what I'm going to do is I'm going to draw a number line for my factors. Okay. I don't want to like list out 1, 2, 3, 4, 5, 6, 7, 8 because my greatest common factor, I'm sorry, my least common multiple is 63, and I don't really want to make my number line all the way up to 63. So I'm just going to start off by listing my multiples of 9. Okay, so multiples of 9 are 9, 18, 27, 36, 45, 54, 63, 72. I could probably, I know I could stop here because I know that's my least common multiple, but just keeping on going. 81, 90, so on and so forth. Okay, so I know that for 9, these are my multiples, because 9 times 1 is 9, right? 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. So on and so forth. Okay, so these are all my multiples of 9. Okay, so I'm actually going to, on the bottom of this, do the multiples of 21, because the problem is least common multiple of 9 and 21. So for 21, my first multiple is 21, which would be like right here. So there's 1. 21 times 1. 21 times 2 is 42, which is going to be about right here on my number line. Okay, so 21 times 2 is 42. I'm not lining up yet. I haven't met the same number. And then 21 times 3 is 63, which is right here. And that is the one they have in common. Okay, so the least common multiple is 63. So you're just jumping on your number line until they both line up at the same number. The last way that we are going to find the least common multiple is using the formula. So the formula to find the least common multiple is the least common multiple of two numbers of A and B is equal to the two numbers multiplied together, A times B, divided by the greatest common factor of those two numbers. Okay, so for that problem we just did, least common multiple of 9 and 21 is 9 times 21 and then divided by the greatest common factor of 9 and 21. Well, 9 times 21 is 189. And then my greatest common factor of 9 and 21, I kind of did that a minute ago when I was doing the prime factorization. The greatest common factor is 3. So then I do the math there. 189 divided by 3 is 63, which is the least common multiple. Okay. So let me go back to that Venn diagram. We did a Venn diagram for, where's it at? There we go. We were doing the greatest common factor. So if the greatest common factor on your Venn diagram is the middle, what do you think the least common multiple would be? Well, if you think about the problem, to find the least common multiple, you do what they have in common times whatever's left over. So the least common multiple is actually everything here. Okay, so for this problem, for 12 and 16, the least common multiple would be 2 times 2, which is 4, and then times everything else. Times 2 times 2 times 3. So in this problem, it'd be 4 times 4, 16. 16 times 3 is 48, I think. Yes, 48. So the least common multiple of these two is actually 48. Okay, so you'll have some of that on your homework to practice. Like, I'll give you two numbers, draw a Venn diagram, find the least common multiple, find the greatest common factor, and shade in on your Venn diagram where your answers are at.